Good afternoon. We start my timer here so I know that how long to talk. So hopefully by now, pretty much all of us have come to realize that we really are at the start of a new sort of era of computing that I like to call the Ambient Computing Era. The age of personal computing is done. And we're moving into a world where we're just surrounded by computing devices, intelligent devices. And, I guess my view, I'm expecting sort of web technologies to be the driving force for those devices. So if we think about this new era of computing and the technologies we're likely to be using, so each previous era has had what I think of as its canonical programming language. The first era for corporate computing, but there was COBOL and Fortran basically, which were different languages, but there were kind of two specialties in computing back there, business and scientific. And then as the personal computing era emerged, it was really C that emerged as the dominant language, and then the C family, eventually C++, and even Java, you can think of as a derivative of C, as they sort of defined what programming was like for the personal computing era. If you're a programmer over the last 30 years, you really should know C. So as we move here into the ambient computing era, I guess my expectation is I think JavaScript is going to be the dominant programming language. And so it's really important that we look at the state of JavaScript today and how it's going to evolve if it's really going to fill this role as we go forward for the next 30 or 40 years. So one of the things some people ask, why JavaScript? I mean, there's so many other languages that are so better in so many ways. And the answer really is, it's a phrase coined by computer scientist Dick Gabriel, who was one of the designers of Common Lisp, and the idea is worse is better. It really doesn't matter if you have what the best technology is. What matters is the economics of ubiquity. What is available everywhere is the thing that people will use. It has the lowest risk, it has the widest availability, and JavaScript has, through chance as much as anything, I think, found itself in that role. It's hard to think how any language, at least in the web-based ecosystem, could displace JavaScript. To the degree that it's tied to the web platform, you have to think about what would cause all the developers of the web platform to say, I'm going to incorporate another language in addition to JavaScript and do it in a coordinated, timely manner that you all could actually start using that other language. It's just hard to imagine how it would happen. So that's really why I think, that's why I became interested in JavaScript. I just sort of looked at the evolving web technologies, the position JavaScript had, and said, this has got to be it. Now, this is after a career that I was involved with some much more beautiful languages like Smalltalk. I was heavily involved in the development of Smalltalk as a practical language and its commercialization, and so I sort of understood the language beauty trip. What's the most beautiful thing you could do and how do you push it? And I sort of realized after a while, well, that wasn't really what made the difference. It was really just factors coming together that says this particular technology at this place and time is in the right place, and it's the pony to ride. And so I got on the JavaScript bandwagon. So if JavaScript is going to have this position in our world going forward, I mean, one of the things it's important to look at is exactly how does JavaScript evolve? How does it get better? Because even if we start with a worse is better language, over time we want it to become a better is better language and stuff. So how's that going to happen? And JavaScript, I mean, one of the things that makes it so unique, but also so powerful, is it isn't controlled by anybody. It's not a language that belongs to any company. You can't, any browser vendor, if they want, can go implement some new feature, but nobody's going to use it, because unless everybody implements that feature, then it's of no use to web developers and such. So what is it that drives JavaScript evolution? What causes new features to be adopted? What's the process? So I'll talk a bit about that as we go on here. But first we'll start with sort of JavaScript's creation myth, which was that JavaScript was invented in 10 days in May in 1995 by Brendan Eich. And Brendan claims this is true. Now, what I also know is that before those 10 days, he'd been thinking for a number of months about building a scripting language for the web, and that after those 10 days, as we look here, sort of the early history, there was a fair amount of refinement that took place over about a 6-month period. But it is true that JavaScript sort of sprung from whole cloth over the course of the last half of 1995. So very quickly, it was a small language, it was a simple language, and there's a lot of decisions that were made at those initial times that actually have profound implications for how the language works. So for example, all of you who are JavaScript programmers know that the language is very, in some ways, forgiving, annoyingly so some cases. You try to add a number in a Boolean, well, you'll get something out. You try to access a property and it doesn't exist, well, you still get a value that you can do something with, or not. You get undefined or something. But so one of the reasons it behaves that way is because the first version of JavaScript didn't have any built-in error handling. It didn't have an exception mechanism and stuff. And so so Brendan designed the language in a way that anything you did produced a value that you could just continue going, right? And so to this day, we're living with all these the implications of that decision, even though exception handling was eventually added to the language and stuff. But it's, again, the very shape of the language and how we use it was largely determined by some of those initial decisions. So JavaScript, was first introduced by Netscape into the Netscape browser, and then very quickly Microsoft implemented a version of it that they called JScript. And so as soon as you have two implementations of something, particularly in the web environment, there's a need for interoperability. And so that led to the formation of a standardization process. And again, this all happened very quickly in the late 1990s. The first ECMAScript standard, which is the standard for JavaScript, and it was called ECMAScript because JavaScript was a trademark of Sun, and Microsoft called it JScript, and nobody could figure out what name to make, and it was being done. The standard was being developed in the context of ECMA International, which is a standards development organization, and somebody said, let's just call it ECMAScript. And so that's what they called it. So the first version of the ECMAScript standard was released in, I think it was 1997. It was actually published. And then over the next couple years, that standard was refined. Features like regular expressions and exception handling was added. And in 1999, ECMAScript 3 was released. And that basically defined the baseline of modern JavaScript. And most of what you're used to today in all your JavaScript programming are features that were available in ECMAScript 3 in 1999. So what exactly is ECMAScript? Like I said, it's simply the name of the standard. Some people have this idea that ECMAScript and JavaScript are two different things, or that JavaScript is a subset or superset of ECMAScript, or something silly like that. And none of that's really true. It's simply the ECMAScript standard is the standard that defines JavaScript. And all the JavaScript implementations you use, V8, SpiderMonkey, WebKit, JS Core, Chakra, if you're use IE these days, these are all just implementations of the ECMAScript standard. So the standard itself is the group within ECMA International that develops the ECMAScript standard is called TC39, Technical Committee number 39. So you'll see on the web and stuff every once in a while references to TC39 or people cursing TC39 or what have you. But that's the group of people who actually work on the standard for ECMA. And the actual standard has a document number. It's ECMA 262. So sometimes you'll see that as a term that's used to refer to it. It's also published by ISO, the International Standards Organization, and they have another number that has 262 in it, but no one really pays much attention to that. It's the same document. But one of the most interesting aspects of it, it's not part of W3C, this whole process. The creation of the ECMAScript standards happen independently and parallel with all the other web standards that take place in the W3C. And for a number of years, there was quite a gap between what was going on in W3C and what's going on in ECMA. Fortunately, the last couple of years, that's beginning to change. We actually have a fair amount of cross-membership now between TC39 and in particularly the W3C TAG, Technical Architecture Group. And so we're kind of keeping things aligned, hopefully, between what's going on in W3C and ECMA. So immediately after ES3 was finished in 1999, people started thinking about doing JavaScript right, really taking this small, simple language and scaling it up to make a language for a more robust language for doing more complicated things. And work started on what was assumed would be called ECMAScript 4. And by 2000, 2001, there were actually pretty complete drafts for something that was called ECMAScript 4. And ECMAScript 4 had a lot of features in it, like classes and type declarations and sort of more conventional features than base JavaScript. And then sort of interest in it ran out. Microsoft kind of diverted all of their energy away from Internet Explorer and the future of JavaScript. Netscape imploded or exploded and was acquired by AOL. And there was really nobody much working on the future of JavaScript anymore. And so that first attempt at doing ES4 sort of just withered on the vine there. And there was a couple years in there where some folks came in, and these were the days when XML was going to be everything for the web, and did some work to add XML extensions to JavaScript. That work took place and got finished and was basically never adopted anywhere significant. And then around 2005, 2006, after Firefox was launched and became successful, there was another round of interest in kind of moving forward with the evolution of ECMAScript and the ECMAScript standard. And so that was, so work on ES4 started again. And there was another big attempt to do a new version of JavaScript called ES4. Took some ideas from the original ES4. Took some new ideas, had a fair amount of sort of academic influence. And it also failed. It failed for several reasons. One of which was just too ambitious, and I think it was too much of a discontinuity from the existing JavaScript the way it was being pushed. But it didn't, it basically was abandoned in 2008. And then in 2009, ECMAScript 5 came out, and ECMAScript 5 went back to ES3 and did some fairly simple extensions of that to take into account what had actually happened in browsers over the previous 10 years, things like the emergence of JSON and a few simple features, but it was sort of a small extension to ECMAScript. Now, I think one of the reasons ES4 didn't work out was, in fact, because the world of browsers really wasn't ready for a significant new version of the language. The real problem in 2007, 2008, 2009, as people started to build more complex AJAX-style applications, is that JavaScript implementations were too slow. And so all the energy among the people who implement JavaScript was on JavaScript performance. And if this new version of ECMAScript had actually been dumped on them at that time, you'd have to wonder what would have happened to performance and which was more important in context at that point in time. Getting high-performant JavaScript implementations or having a bunch of new features. So this is just SunSpider from 2008. And I actually found it's kind of hard to actually find good benchmark data from more than a couple years old. But if you look at SunSpider in 2008, you can see that all the browsers here were on SunSpider were in the kind of 5 to 30 second range to run SunSpider. And in 2013, you look at all the browsers, they're all here in the 100 millisecond range, right? So the performance hurdle was sort of conquered. People are now trying to do amazing things with JavaScript, and the time seems right now to actually move forward with improving the language from a programmer's perspective. And that's really where we are with ES6. A way to look at it is sort of the overall timeline of developing the ECMAScript standard. We had this initial period where things went well. There was this big diversion into these various black holes of various versions of ES4 and E4X. We got ES5, and now we're kind of back, taking some of the ideas from from the ES4 age, but other ideas, and really moving that into ES6. And ES6 is almost done. It's feature complete. We hope to publish the final specification this year. Keep our fingers crossed whether we make that or not, but it's there, it's real. It's not like the state ES4 was in. And ES6 has really a huge number of improvements, and this talk isn't one where I'm going to go through all the features of ES6 and stuff. There are a lot of resources out there where you can go read about individual features, and particularly the link up there, Luke Hoban's GitHub page is really a great summary of all the major features, giving you examples of their uses and stuff. And if you want just an overview of what ES6 is about, that's what I'd suggest a good starting point. But just as an idea of scale, the ES6 current draft is 650 pages. ES5, 5.1 was 250 pages. So it's a huge amount of work to produce this new edition. Now, not all of that is in new features. One of the things we do with every edition of ECMAScript is we make the spec more and more detailed to ensure that the browsers interoperate, that they all know exactly how to implement each feature. So some of the additional material is more detailed specifications, a part of JavaScript that had not been so well specified in the past. And these features are being implemented. What you're going to see, I think, is not one big bang release of all the ECMAScript features, but each browser will roll out features incrementally. And we're really seeing this across the line of all the major browsers. Even IE is starting to become pretty aggressive in terms of implementing ES6 features. And so this is a website you can go to that tracks the individual features and which ones are starting to show up in different browsers and stuff. And so again, this is real stuff. Work is happening on it. It's going to be real. So I want to talk a bit about TC39 and how it works and kind of what the process is we go through in developing standards like this. So people have various ideas of what something like TC39 is like. Some people think that something like this, it's this big group of people and it's very formal and we vote on things and stuff. And it's nothing like that at all. And some people think it's more like this. You know, it's a big high-stakes poker game where you get Microsoft and Mozilla and Google, and we're all here, you know, playing our hand and trying to be tricky to see who's going to dominate in this browser game. And it's really not like that at all, too, either. It's actually more like this, although hopefully we don't look quite that way. But the members officially of TC39 are companies, and then companies decide who goes there and stuff. And so the major players you would expect to be there are there. It's again, Google, Microsoft, Mozilla, Apple shows up sometimes, and then there is just starting the last few years, we're starting to see interest in people like Netflix and Facebook are starting to realize it's important to be involved in the evolution of this technology, and we're starting to get some people. It's actually, if you've ever been on an engineering design team where you get into a room and you debate technical issues and yell at each other and fight about ideas and make decisions and try to keep moving forward, that's what it is. It's really just like any complex engineering process, but it happens to be staffed with people from a variety of companies. And it's not even necessarily the case that all the people from any individual company actually agree on any topic, right? So again, it's not like there's necessarily a fixed agenda from each company and stuff. It's more arguing about what is best for this language, how should it evolve. And this isn't all the people, but I got tired of trying to find pictures after a while, but this is a pretty good representation of the core group of people who tend to show up regularly and participate in the process. Now, my job in this, so I may actually be the only person whose official full-time job is mostly working on ECMAScript. And my job is editor. Editor pretty much means author. So as we agree on features and we sketch out details of those, well, somebody has to write down a very precise specification of those and incorporate it into that document and look at how that each feature interacts with all the other features and stuff. And that kind of ends up being me as editor. So that's kind of my job in this overall process. And so what I want to do here is, for the rest of the talk, I kind of want to delve into what it's like to kind of work on designing new features for a language like this. Kind of the thought processes we go through and the challenges we face and such. So, obviously one of the first ones is the core of the language is established. It is what it is. You may or may not like what it is, but you can't change what it is. And so as you grow the language, elaborate its features, you got to be very careful to kind of maintain the spirit of the language. You don't want something that looks like this, although it's kind of cool. That's really not the end result you want to come out of the language evolution process. Or another thing that you learn very soon is you can never lose the baggage. Things that are there in the language you're stuck with, and you really can't change them. One of our overriding principles in evolving JavaScript is we don't want to break any code that exists out there in the real world. There are millions of websites that have no active maintenance done on them, and we respect that, and we want those websites to keep working this year and next year and 50 years from now. And so we can't really break existing code. So we're kind of stuck with this baggage that we have, and one of the things we have to do is figure out how to live with that baggage. So I want to look at kind of one particular kind of set of problems we're here and the kind of the features we motivate. Sort of the motivation for some of the new features and stuff and how we address some of these problems. So for any of you who do JavaScript programming, you probably had this bug in your code or have seen code that has this bug, the closure and loop problem. The basic idea here is you got a loop, and you got P, which is the value you're iterating over the loop, and you got another variable that's declared in the loop V, and then you have, you're calling a function and you're passing a callback, a functional argument, and that happens to reference V and P, and you're stashing these away for each time through the loop, and then sometime later, those callbacks all get called. And the question is, what value is V and P going to have when you execute each of those callbacks? So somebody want to give me the answer? Yeah, they're all going to have the last value that you would writing this, you would expect, each of them is going to have the value that they had when you created the closure and passed it in as a callback, but instead they're all sharing the same variable, and so they're all run with the last value of V and P. And that's a problem, and we'd like to fix that, and so that people don't run into those sorts of problems. The basic problem is there's the declarations of V and P, and there's the reference. They all use the same value. And the source of that problem is the way JavaScript hoists var declarations. So even though you've said down here in the head of the for loop var, and inside the block that's the body of the for, you've said var v, the way JavaScript really interprets that is it takes that v and p as declarations and hoists them up to the top of the enclosing function. And so there's only one p and v that all these closures you create see that is independent of the for statement and the block body, that's the body of the for loop and stuff. And so it's this var hoisting that causes the problem. So you might say, well, can't we just redefine the scoping of var so that instead of hoisting it, that it's local to the for statement and the block body? Well, you can't, because what I said about we don't want to break any existing code. And code exists, you see it all over in the real world, where you have things like var v declared in a block, and then outside the block, somebody is still referencing the value of v and expecting it to be whatever the last thing was set inside the loop. So we can't just change the semantics of var and say we don't hoist, because that would break all the existing code like this. Now, it turns out, by the way, there are lots of other local scoping WTFs with classic JavaScript and with var declarations. Some of these you may be familiar with, others you may not. Things like, did you know that you can use the same parameter name for more than one parameter? So, the basic question here for this whole thing, what value of x are you going to have? Right, so you can have multiple parameters with the same name. You can, then declare a var. You can declare another var as the control variable, the for loop. You can, deep inside, you can keep declaring var. You can have declaring x. You can have a function named x. You might, one of the questions you might ask is, well, when you call x down, well, two interesting questions. What's the initial value of x, and what are you going to call here when you call this? So it turns out that the initial value of x up here at the top is actually the function, because the function declaration gets hoisted up to the top and initialized. And by the time you get down here, you'll have gone through the for loop, and you're going to get either the value of x that was assigned here, or maybe the value that was x that was assigned here. So you're probably going to try to call here something that isn't a function. So it's just craziness, right? Is what's going on here and stuff. And we'd really like to straighten this out. Now, just as a quick aside here, you might say, well, isn't this all edge cases? Why are you worrying about all these edge cases? And what I always tell people is, edge cases are my life. That's the only thing you need standards for. Everybody agrees who implements this stuff what the normal cases should do. It's only the edge cases that people disagree about, but it's the edge cases that really cause the interoperability hazards when people fall into them, that causes code to work in one browser and not in another browser. So as part of developing these standards, we really have to pin down all these edge cases. And so that's, again, the life of a language designer for a language like this is all about thinking about these edge cases and what to do about them. So for ES6, how do we fix the closure and loop problem without changing var? Well, it's actually pretty simple. We'll introduce a new way to declare variables, and we won't call it var, we call it let. And we can then, since it's new, we can say that, okay, let has the sort of block scoping you'd expect to see in C or any other more conventional language. And so when we say let P here at the top of the for loop, we can define it so that each iteration of the loop gets a fresh P, and similarly the V here inside, the declaration of V inside the block body of the for loop, we can define it to be a new variable binding. And so each function closure we create that reference V and P actually is binding to a separate variable. And so each of them sees the V and P value that were alive when their particular iteration of the loop ran through, and everything is fine. Everything works the way you'd expect. So as an ES6 programmer, all you really need to learn is don't say var, say let. And then things will pretty much work the way you want them to work. But, there's always buts, but now we've added something new to the language, and we have to think about how it interacts with everything that's already there. And we don't want to introduce a bunch of new WTFs that relates simply to let. So, we have to go through looking at all the sorts of funny things you might do and how do we want to handle them. And since this is new, we can now make decisions. We don't have new decisions. We don't have to do what we did with let. So, for example, issues we had to think about were, well, what happens if you say let more than once? What happens if you say both let and var? What happens if you say let, but you also have a parameter name for the same thing? What happens if you say let and you have a function of the same name? What happens if you have a let out here in an outer scope and a var down in the inner scope? Now we know vars always get hoisted, So this var kind of moves up to the same level of scoping as the X. So what happens? So fundamentally, the decision we made in all these cases, since these are things the JavaScript parser can actually detect as it parses the source code, they're static errors. We could have made other choices. We could have tried to make them work somehow. We could have tried to make them dynamic errors if you only got an error if you actually encountered something that was ambiguous. But we really said all these things, there's no reason anybody should code these things, right? And so if you code this, it's like you had a syntax error in your program. You get an error, your program immediately terminates. You should find that during development time, not when you deploy it at runtime. But even with that, there's still real additional issues to consider that we had to make decisions on. For example, consider down here is a function, and it declares, towards the end of the function, it declares uses a let to declare a variable x and sets it to a value. But prior to that declaration, it references x. And note, there's also let declared in an outer scope to this function. So the question is, what happens here when you reference x? Do you get 1 because this new declaration hasn't happened yet? Do you get undefined because this is in the scope here, but it hasn't been initialized yet? Do you get some sort of error? And so these are questions you actually have to consider and make decisions upon. Now, the decision we made, and then we applied overall throughout the language design, was that within a block, so like this block here, every name only has a single consistent binding. So for this reference to x to get the binding from this outer x, but another one later on to get this one in the same block would be an inconsistent application of that name. And so we said, that's an error. You'll get, again, one of these static errors when you try to compile or load your program that says, well, actually, you don't get an error. Sorry. In another situation, you get an error. But the important thing is, you never, since you have a local declaration of x, you'll never see that outer x. You never have anything leaking into the scope. A similar thing is what happens when you have a forward reference. So now here we've moved a reference to x ahead of the actually we've assigned x ahead of any reference to it, but before the actual declaration and before it was initialized. So again, you could ask here, when we first reference x, does it get 2? Does it somehow magically get 3? Is it undefined? Is it an error? There's all an argument could be made for each of those possible outcomes for a forward reference inside a block. And it becomes maybe a bit clearer. So we also have const declarations, and const is just like let, except for a const must be initialized, and it can only be initialized once. And so again here, we reference x. Our rules say we have to have a single consistent binding. What's the value going to be? Because we haven't got to the initialization yet. So sort of 3 or error seems like the plausible values for it to have. So the design decision we came to was, well, there needs to be a dead zone, basically, that even within a block where you have a declaration, before you come to the actual declaration and the initialization, you're in a dead zone where if you try to reference that value, it will be an error, okay, because you're referencing something that hasn't been initialized yet. So that's a characteristic of ES6 if you use the new declaration forms. But it's not that simple. Nothing is that simple because, sometimes forward declarations are useful. So, for example, here we're defining 2 consts. whose values happen to be functions, and these are mutually recursive functions. Okay, and so to write mutually recursive functions, one definition has to forward reference the other. And so if we simply said, this first one is in the dead zone for R2, we couldn't write this. So a static dead zone would be way too restrictive. So what we ended up with in ES6 is what we call temporal dead zones. Okay, and what temporal dead zone means is that you get an error for accessing an uninitialized declaration based upon the status at the time of the actual access. So not upon the position in your source code. And every binding must be initialized before it's accessed. So in the case here, we can still write these two mutually recursive declarations, and by the time we call R1, both R1 and R2 will be initialized and everything will work fine, and there's no temporal dead zone violation, and everything is hunky-dory. So from that, you get a whole set of rules, basically, that say, okay, kind of what are ES6's declaration rules? Got a single unique binding for any name in a scope. var and function declarations of the same name are allowed, just like for ES5, because we can't break any existing code. Any other multiple declarations like var let const, class function, etc., those are all errors because it's new stuff. There's no existing code we have to protect. var declarations still get hoisted because that's ES1 through 3 semantics, but you can't hoist a var over a let because that would cause confusion, and there's no compatibility issues with that. And then we got our temporal dead zones and stuff, and so that's kind of the core set of declarations. But hopefully they're just intuitive. They're what you would expect to happen, and that if you get an error, you're doing something, if you look at it, it doesn't make a lot of sense. So one thing I didn't talk about here, and it's another sort of complication we run into, is what about putting a function declaration in a block scope? For example, if you declare a function here inside of this block, can you reference it out here? You would think no, because that would violate block scoping. Or if you have multiple declarations of G like this, and in the middle you call G, is this allowed? And if so, what value does it get? So the interesting thing is ECMAScript 1 through 5 didn't define any meaning at all for function declarations in blocks. So you would think we could define whatever we wanted for it, just like we did for let. But the problem was, even though the standard didn't define it, real browsers allow it to happen. Okay, and real browsers agree, for example, that if you write something like this, if you declare V inside a block and then you call it after the declaration, well, it's going to work pretty much what you'd expect. So that's good. That's consistent with lexical block scoping of function declarations. That's what we want. But the problem is, but real browsers also disagree on things. So they, for example, disagree on, in this case, where the function declaration inside a block is referenced before the declaration, is G defined or not? Turns out in some browsers it is, in other browsers it isn't. Or another example, you define G in the block like you'd expect, but you also have a declaration of G outside the block. When you get to this G inside the block, which G does it call? Well, it turns out some browsers call the G from inside the block, and some browsers call the G from outside the block. Okay? Well, actually, disagreement is good on non-standard features, because if there's disagreement, you know that there isn't any interoperable code that works across browsers that depend upon that feature. So you can define what you want it to be, and basically that's the one opportunity you have to make a change to something that already exists. Unfortunately, all browsers also agree on this, which is that if you declare a function inside a block, you can reference it inside the block, but you can also reference it anywhere beyond that block, okay? So that's a violation of block level scoping. So the question is, what is the common interoperability that we have to define for block function declarations that preserves the existing code yet still meets block scoping? And you can study this code if you want when I make the slides available, but fundamentally it means we have to do the block scoping, but we also have to hoist the binding to the top level so it's visible outside the block, except for we don't do it if it would violate any of those other rules. So it turns out by being really clever, we can actually get by, we can have function level, block level scoping and still have interoperability with existing code. And so just getting back to our you can't lose the baggage, you can't lose the baggage, but sometimes you can repurpose the baggage to make it, a little bit more useful and stuff. So, just to wrap up, ECMAScript 6 is really real. It's feature complete. It's being implemented in browsers. And over the next 2 or 3 or 4 years, it's going to be the version of JavaScript I think you're all using. And there's a lot of resources out there on ECMAScript and ECMAScript 6. And if you're interested, I encourage you to dig into these or talk to me and I can give you more pointers. So thank you.